And welcome to Desk of Lady Ada.
Hello and welcome to yet another Desk of Lady Ada. I'm Lady Ada. With me is Mr. Lady Ada.
Hi.
Who you can hear as a disembodied voice.
I have a microphone now.
He has a microphone now and he's experimenting with 1080p transmission.
We're trying some stuff out.
Boom.
Another setup, another day, lots of experimentation.
Desk
of Lady Ada is a rapid prototype. This is a rapid prototype for all things. Speaking of...
A rapid prototype.
Speaking of...
Yeah.
We're making a robot.
We are making a robot.
All right. Let's do this.
We're going to make a robot. So we've been working on this robot, and we had some ideas. And last time we talked about cardboard robotics. And I kind of decided it's time to quit the jibber jabber and start time. It's time
Less
to
jibber jabber, more robot making.
More robot making. And so I thought we would do some engineering, and I thought we'd actually start by maybe looking at what we've got. I'll close everything out. So I was doing all sorts of things. Looking at the Adafruit shop.
I'm going to go to the computer.
Seeing what we've got. The computer. We've got a bunch of stuff in robotics. And I'm actually going to steal from myself, which is the best kind of theft. Right? When you're an engineer or a writer or an artist, musician, steal from yourself. Like, why not? You already did the work, do it again.
My favorite thing is when I'm looking up something online, I'm like, oh, I wrote an article about that 10 years ago.
Good work, past you.
Yeah.
So we got some things. So again, I know nothing about robotics. I'm very robot ignorant. I've never really built robots. I'm not like a robot fan. So that's good and it's bad. I mean, the good thing is that it means I come at it with a very fresh mind. I don't have any like preconceived ideas. The bad thing is that sometimes I don't really understand what people want in a robot, but I'll figure it out. I don't mind revising. I don't mind doing it again. You know, that's part of life. So I've got the motor shields. This was a successful. Anything that's at the top here, it's kind of sorted by popularity. So people like this. This shield is really simple, but it's the second version of my robotics shield. It has 2 stepper slots. Each stepper can do 2 H-bridges, so it's like 4 motors or 2 steppers. And I've got my favorite PWM I2C driver chip, the PCA 9685. This chip does the PWM stuff for me. So motors is basically like you PWM your H-bridge or you bit bang your H-bridge. With steppers, you tend to just go, pulse high and low. With DC motors, you tend to use PWM to change the speed, the throttle, and then sometimes you can mix and match them. You might want to have like 2 DC motors and 1 stepper, or you might want to micro step your stepper, in which case use PWM. So basically, the previous version of this shield, which I don't even think is live in the store. I mean, I think I took it out of the store like 8 years ago. The original version used L293Ds, which are 800 milliamp per H-bridge channels dual. And I used an 74HC595 shift register to control them. And then in addition 4 PWMs. So basically the problem was that every Arduino has the timer PWMs on different pins, or like some of them are taken, some of them are not. So it ended up being easier for me just to use this PCA 9685, this chip that over I2C I control, and I tell it over I2C set the PWM on this pin. It has 16 outputs. It tells them which pins to have PWM on, and it drives the motors. It basically means that you can run this on any Arduino ever made, and as long as it has the I2C pins in the same place, which it should because they're standard, it'll always work, which is great, wonderful. And this is really only good for steppers and servos. And so those are 2 kinds of robotic things. It's not good at solenoids, and it's not good at servos. I have a different servo driver which uses that same chip, and this one is lined up so you have these GPIOs, these triples, power ground signal, that are designed for your standard servo motor. What, do you have any
Question
questions?
from the chat. Will there be any stepper boards using the TMC 2130 or a variant of that in the future?
No idea.
Okay.
Maybe. Who knows?
All right.
Mystery.
Okay. Keep going.
Yeah, I'm keeping it simple. We also have solenoids in the store. I like to use a MOSFET for those. You can also use ULN. Get the part number. ULN 2803s. These are Darlington drivers. They're great for driving solenoids because they have kickback diodes built in. They can use very high logic level. You can use a stepper motor with them too, a unipolar stepper motor. The ones that you don't need an H-bridge for. These motor things. They've also got the motor Featherwing, which is basically that shield shrunken down. You can see there's 2 steppers you can control, or you can do 4 DC motors. So I was thinking about this, but I think for I've had I have this stepper motor wing and I have the servo wing, but they don't, you can use them by stacking, but there's no board I have that does both, really. And so I thought one of the things that this robot Featherwing, this kind of all-in-one, everything you ever wanted robot controller, would have servo, stepper, and DC motor controls. And so I kind of just start thinking about how am I going to make this work without, again, using every single pin on a Feather, because it very quickly, once you get into motor control, you're like, oh, I need 20 pins and 5 timers. So think about this, but I think I have a solution. So it's time to design. So we're gonna make a new folder, Robo Wing. It just sounds cool. It sounds like a Japanese 1980s anime. Robo Wing.
Join RoboWing.
Join RoboWing.
The flying robot force.
And one of the things that I thought I would do for this robot is previously I'd been using, these are the TB6612 stepper and DC motor drivers, and they can do about 1.2 amps, and they're lovely. But I actually wanted this one to, instead of using the TB6612, I wanted to use the DRV8833, which we carry a breakout for. So again, I'm going to steal for myself. This also has dual H-bridge, so it can drive, each chip can drive a stepper or 2 DC motors. What's nice about them is this has a current limiting resistor setup capable. So the DRV8833 has current limiting, which is really nice. The TB6612 does not have current limiting, but these 2 chips are about the same price. They're about $1. So I can go to DigiKey, TB6612. You can look up this part. Can you read the text, do you think?
Yeah, you can also, enlarge it. Yeah, look at that. Ooh. Do whatever you want.
Amazing.
It's your show.
And under DC motors, these are about in large quantities about 89 cents for the TB6612, and then if you look up the DRV8833, it comes in a lot of different types, but it's only a little bit more. It's 99 cents. It's almost the same price. So a good deal and available in multiple different packages. Actually, this package is 82 cents. It's not in stock, but if it was in stock, it would be, about the same price. So you're paying about $1 per H-bridge. But I want to use this one. It's also better for lower voltage motors, and I thought for this one we would, there are DC motors that are available at the DB6612 voltage range, just basically 6 to 12 volts. But I thought for this motor driver also I would optimize for lower voltages, 3 to 6 rather than 6 to 12. So another good reason to use the DRV8833. It can't pass as much current. It looks like there's a couple different versions. I guess the QFN can actually do higher current, so maybe I'll go with that. But this one's better for lower voltages. but it has current limiting, which again I think is worth it. So let's start with like a basic wing. Maybe I'll grab my I wing or INA wing. Let's see, where did I put that? Oh, it's under Featherwing. I forgot. Let me open.
Oh, Kirby had a thing. Neat thing about the TMC 2130 is it can do sensorless end stops. So if you hit the wall, it could sense it wasn't moving, and you can program it to back up and turn without needing an external sensor. That's cool.
That's another thing you can do with the current limiting resistors is you can tell when you've maxed out the current, like you're stalled. So that's a benefit of current limiting as well. So let's grab. I'll grab this as a structure. Actually, you know what? I'm going to have it be based. I want it to actually be a Featherwing where I plug it in. So I'll actually grab my TFT wing design just to get something in place. But I'm gonna basically delete all this stuff because I only want the basics. I'll delete the measurements. And yeah, I don't want the outline either. Actually, I'll just kind of delete everything. Let's see what's left. Go to this ground plane. Keep the reset button. But yeah, I want it to be, you know, you plug it in. So this style of Featherwing. Because I'm going to need a lot of space. But I like the on-off switch, so maybe I'll kind of keep that over here and over here. And I'll add the fiducial later. So over here, I don't know if I'll have a lot of space, but I wanted to start adding the motor drivers. So back in breakout boards under, let's see, what do I have it under? I think it's under breakout? Motor control. The DRV 8833, and I've got it all kind of laid out so I can grab this and I'll grab all this and paste it. I think I might need another sheet. Maybe I'll make a new sheet here. So I can have like, I have enough stuff I'm going to be pasting in that I probably can't keep it on one sheet. Too much electronics. So let's see. You got inputs, you got the outputs, V motor. I can keep the sensor stuff. This is duplicated. This part, which is the motor voltage input, I think I'll cut this and put it on the front sheet. Kind of belong. I think I want like the main stuff here. So yeah, this is my motor driver. Still, I'm not sure exactly where everything's gonna go, but I'm just gonna kind of start grouping things. So maybe I'll have like my stepper motors and DC motors over here. I'm not sure. And then outputs this way. Let's see, like that. Maybe put that there. Put that there. So I also have this DC voltage input. So it's going to be for my power supply for the motors. They're going to be separate from the lithium polymer power because you know, for robotics you want to have separated power depending on if you're doing, you know, robotics, your motors are going to be really noisy. Want to keep those power supplies separated. I'll put these jumpers. If you don't want to use the current limiting, which I recommend, you can short these out. Okay, so I kind of got a couple things going here. So, okay, so I got some motors, and looks like these just, you know, they're your friendly decoupling capacitors. Maybe put them over here. Okay, so that's good. All right, so we got 2 sets of dual H bridges, so you can do 2 steppers or 4 DC motors. That's good so far. And let's kind of shove this over here. We got the DC input. I also wanted to have this be able to control a bunch of servos, because servos are very handy. Everyone loves servos. So, you know, close up. Look at mouse. For these, you need to have a dedicated timer so you don't have jitter. And this is kind of the question I had, which was, I'm going to need 4 GPIO a piece for these H bridges, because you have A in, B in for one, and then A and B in for the other. And each one's a pair. So I can look at the sheet so you can see this. So each dual H bridge requires 4 GPIO, and there's 2 of them. So before you know it, you're up to 8 GPIO just to drive those motors. And this is where I would use a GPIO expander. Because I want PWM for motor speed control, I would use a PWM expander. But then the moment you start, which is all well and good, you know, you can toss in your PCA 9685. But then the moment you have to control servo motors, you have a conundrum, which is you want to drive the PWM for your DC motors or your steppers at least at like a kilohertz. Like you want it to be like kind of high. You know, you don't have to go to like 10 kilohertz, but servos require 50 hertz, and 50 hertz is a little bit low for servos, for steppers or DC motors. So I would like to separate the 2 PWM timer frequencies, but the PCA 9685 doesn't let you do that. You have to pick one frequency for all of your PWMs. Like you have one clock. So you have 16 outputs, but they all have to run at the same frequency update rate. And that's when it's like, okay, well, I don't want to do that. And then if you do the math, each PCA 9685 is, I think, they're like $1.10 a piece. Yeah, like $1.02. So each one's $1. Again, not a lot, but now you need 2 of them. And I would like to not do that. And as I was trying to add more and more things to my ideas, I was like, okay, well, I have to find another solution for a PWM breakout that isn't the PCA 9685. And that's where like this weird mystery of integrated circuits comes in, which is you can get this really wonderful LED driver with 16 outputs for $1, or you can get a full Cortex M0 processor for like $1. So while this has you know, one timer with 16 outputs, I can get a at SAMD 21E18. For example, oh, this is me. Sorry, I meant my controller. You can get a full 24 kilobyte flash microcontroller with like 22 outputs for less than the cost of 2 of those chips. So it might make sense for me, instead of having 2 drivers, to just have a coprocessor.
What about Seesaw?
I could use a Seesaw.
Oh.
So I already designed this because I knew I would need something like this. So instead of having these individual PWM drivers, I can use my Seesaw design that in-house engineer Dean made live in existence. This one uses a SAMD09, But the core is adaptable for any SAMD processor. It's quite smart, and so you can configure it. And even the smallest of the SAMD 09s has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 GPIO. So the 50-cent one has 18 GPIO, so upgrading to the SAMD E, which is a 32, will give you even more GPIO, and you get like all the timers you get, which is a lot. You can, there's I think 3 or 4 different timers, and each one of those I think has 4 to 8 GPIO that it can control. So it's plenty, and they're very fast timers, and it can be in 16-bit mode if you want, or 8-bit mode, or whatever goodness you may desire. So even though the Feather itself might have a SAMD 21 on it, or maybe it has an ESP8266, I would like to add a SAMD like Seesaw edition on there. So let's go and I can grab from my trinket design a known good setup for this. I will grab it like this. I don't need the regulator stuff. I don't think I need the LED either, but I'll grab the USB because why not? So this will be my Seesaw coprocessor helper friend. It's of course massive chip. I don't know if I want to keep this APA 102, but maybe for now I will. And I got lots of pins. So I've got, besides these 2 pins, which I may not need, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I've got 20 GPIO. So if I have 8 dedicated to the motor drivers, and then let's say 4 dedicated to servos, I've still got 6 to 8 left over that I can use for whatever. And then I'll leave the D- D+ available. And of course the SW clock and SWDIO I can use for like an LED if I wanted to. Those are not a big deal. Okay, so I don't need this reset because I will share the reset lines. So let me call this reset. That's reset. Great. So now I've got this little friend, and just to make debugging easier, I'm going to have the USB on board, but I can remove it later, or I can just have some non-confusing GPIO. This is just for like when I'm debugging and designing the Seesaw. I'll leave this LED here because why not? No harm. And then there's like an indicator.
Kirk says nice. And let Seesaw do the stepper pulse generation.
Yeah, why should we do it?
Yeah, we got the Seesaw.
Why should I do that? And then I'm going to change these, instead of having them be pads, I'm going to change this to be a proper breakout. Let me see if I've got my 2x05. Oops, I think I don't.
Question, is the APA 102 just an RGB LED driver?
Yeah, it's just an RGB. It's from the Trinket. It's just good for debugging. I like having an indicator, and it's like 5, 6, 7 cents or whatever, maybe 8 cents. So it's only a couple more cents than a red LED, but you get, of course, like every color, so it can be handy. A red LED usually just tells you, like, it can just blink in different patterns, but an RGB LED can be like green for go, or yellow for like halted, or red for fail. So it can be nice for debugging. Let's put a proper SWD port on here. I've got my JTAG Cortex connector, and I'll get rid of these. These pads are good for the end, but while I'm actually doing the debugging, I'll have proper.
All right, on the Lady Ada timer, you got 15 minutes.
Yeah, we're gonna wrap up in a minute. I'm not gonna.
All right.
I'm gonna only do this layout part, and then
here's another question: will this Featherwing have any kind of sensors?
What was the question?
Will this Featherwing have any type of sensors on it?
It might.
Oh, it might.
I don't know yet.
Okay.
Still thinking about it. So SDWIO. Get that there. SW clock. And then... See, this is going to be... I'm going to have this actually be a separate reset. So when I'm debugging, I don't want to turn off the domain feather by accident because I'm toggling the reset. So that's good. Okay, how are we doing over here? All right, great. So got a little debugging port. Toss that over here. I think I'll keep this LED for now. I'll do something with it later. Okay, so this is my coprocessor, and I have to actually look up in the pin mapping table because there's a lot of timers, so I don't recall precisely which pins do what, where, because I'll want to use probably an 8-bit timer for the motor control. I don't need more than 8 bits. So like, you're not going to get precision motor control from PWM. For the servos, though, you do want to have a 16-bit timer. You don't get enough resolution from an 8-bit timer. So you need at least, like 12 bits is really good, 16 bits is better.
Okay, 4 or 5 pins available after motors. Can't leave those open pins, right?
Well, you can leave anything open. You don't have to use them. You don't want.
And then someone said Hall effects sensor would be nice. So there's a vote for sensor maybe.
Okay. This is my sort of chunk of motor control. These are servo pins, so this will give you 4 servo pins. So I'll start making notes about how many GPIO I need. Actually, I'm going to take this and I'm going to bring this over to this area. It's just for placement right now. Okay, and then I need 8 PWM for motor. 8 times 8 bits, and then 4 times 16 bits PWM for servo. So it's just a note to remind me later when I'm like, hey, how many pins do I have available? So that's that. Okay, but I'm not done. I want to add a couple more things. So we have motor, we have 4 motors or 2 steppers, we've got 4 servos, which I think is a good number. What else did we want to add? We wanted to add some solenoids maybe?
Yeah.
Maybe 2 solenoids is a good number? What do you think?
Yeah. Someone's asking about IR. We have another Disco Lady where we talked about some IR stuff.
Yeah, IR is tough because even though it's tempting to put the IR under the Seesaw subcontroller, IR is very hard to do because it's so interrupt driven. It's an input, not an output. So I think if I do add IR, which I've been playing around with, I'll probably add that natively on the feather pins rather than through a controller. It's just really, really hard to get the timing right. And you have to structure the data. I don't think it's going to be easy enough. I'd rather do IR natively. But one thing I can do through Seesaw very easily is NeoPixel control. So I can add. So let's add the. We want to add 2.
Oh, did you say what the clock rate on this PWM divider is?
Well, I haven't set it yet.
Oh.
It's whatever I want it to be. So 2 times GP general purpose output for solenoids. And then I can add just 2 and 2 2 2. Well, the 2 2 2s are not going to be very large. I could put in a proper FET like this one, a DMG. That one would be probably better. I'll put that over here. And then, oh wait, I want it to be like this. And then maybe grab sort of this is where your solenoid would go. And then I'll need a, don't have any diodes. Okay, I'll turn this into a surface mount diode layer. But I can do a little diode. I think I got the polarity right. I always get this wrong. It's, yeah, negative because it's going up. And then this is ground. And then this would be my solenoid 1. So 2 solenoids. Why not, right? I think 2's good. I think more than that, you're like, you should get a solenoid driver. What do you think?
Yeah.
I think I could look at the price of those ULNs. ULN, was it 8 something? I always forget the part number. ULN 2803.
Some and shaft encoder inputs for closed loop servo.
Yeah, I'm probably not going to do anything with closed loop stuff. It's not that kind of robot. And, I mean, there'll be GPIO available, but, you know, for encoders, you're going to have to do the work of the encoder. And I don't think I'm going to... I mean, I could add GPIO for it, but the code for that, like, you have to have it be a closed loop control. You're not going to be able to do that on a separate coprocessor. So, 60 cents, I don't know. I mean, do you think people are going to want to control more than 8 solenoids? Could add one of these.
Pro version.
Pro? Okay, stick to 2. Okay, so maybe 2 solenoids. All right, I think that's a good start. So.
Yeah. Okay.
Yeah, I got servos, stepper, solenoids.
Other requests: big Darlington pair to control big current motors.
Yeah, this is. I mean, like you can drive about 1 or 2 amps peak from each of these H-bridges, but then if you just want to have a solenoid turn on and off, these little Darlingtons. This is a 4 amp transistor. It looks small, but it's quite powerful. You would be able to turn on and off and turn on and off for your large motor, want you to single direction, or your solenoid as single direction. I think that's a good start. What do you think?
This is good. This is an excellent start.
Okay, great. All right, that's it. That's what I got. I'm just gonna make one way things sort of line up. Yeah.
Okay, well, this is a good start later.
Okay, good start. It's all about the start. All right, so this is so far robotics land. So maybe next time we'll look at, yes, hello. We'll look at sensors, other outputs. So maybe infrared. We talked about infrared. Maybe we'll look at how we want to hook up infrared. NeoPixels. We want to add some on board. We can add an output for them.
Yeah, folks asked about gyros, accelerometers.
Yeah, I don't know. That's the thing. I don't know if I want to add. I don't want to have it do more than what it does, because if the thing is, if you had a gyro, you'd probably want it to be on the thing. This is sort of meant to be a separate.
Okay. Another question. This isn't for you, but it was in the chat.
Yeah?
Why BJTs aren't FETs better for high current control?
FETs are going to be a little more expensive, but I stock them. I don't have any good high current. I don't stock high current surface mount BJTs, so it's like it wouldn't really matter. But I have these 4 amp ultra low RDS on MOSFETs. I might as well just use them.
Okay.
Although I think I just picked my PFET, not an NFET, so I got this. I always get these confused, so I'm gonna have to grab my NFET here. But I have to look up the part number.
Okay. That's it for tonight, folks. Don't forget, we're about to close off the AdaBox subscribers. So I have a little AdaBox video.
Yes.
Go to adabox.com. Sign up. Quarterly. Delivered. It's fun. AdaBox 07 is massive.
Yes. So much.
AdaBox 08 might have some interesting things in it, but you have to be a subscriber because it will only be in AdaBox 8. So that's all I can say about this. Okay.
Okay.
I'm going to play this thing. Bye.
Okay, bye.